guys, welcome back to my new videos, that is closed loop control of the phase shifted full bridge converter using Matlab Simulink. The circuit diagram shown here is the full bridge converter and the leakage inductance, and the transformer will be there, and after that here the inductance will be the filter and the capacitor will be there. The voltage controller, we are going to use the PI controller here, and after that of saturation block, and we are going to generate the gate pulses using here. H is the feedback transfer function and will be feedback from the VDC. The design specifications are the input voltage will be 210 volts to 373 volt. Output DC voltage will be the 50 volt, 54 volts. The switching frequency is 100 kilohertz. The rated power of the converter is 540 watts. The maximum cycle loss will be the 0.15. The output ripple will be the 2 volts, and output inductance ripple current will be the 0.2 ampere. The crossover will be the less than 10 kilohertz, and fair margin is 25 degree. Now open our Matlab Simulink. Now go to Simscape, electrical, specialized. Take series RL branch. Power electronics. Required MOSFET. MOSFET diode. We'll take the linear transformer. We required DC voltage source. Now we will connect our circuit as per the diagram. In the source to drain, drain to drain. Connect the positive to the drain and negative to the source. Change the voltage to 210 voltage and change these two. We required L for the leakage inductance. We will going to define is 23.62 microhenry. The L value will be leakage inductance. Okay. Now we will connect to the leg first and to the transformer winding. Now in the transformer unit, change the parameter to unit to SI. Okay. Change the voltage to power will be the 600, and the frequency will be as we have defined the frequency as 100 kilohertz. The VRMS for the winding, RMS will be 18 volt, and resistance will be 0.05, and the inductance will be 9 e power minus e power 7. Okay, and for the second, the winding 2, the voltage will be the 6 volt, resistance will be 0.05, and the inductance will be e 1 power minus 7. The same will be for the winding 3, and for the magnetizing resistance and the inductance will be e power plus 6 ohm, and the LM will be, magnetizing inductance will be 10 millihenry. Okay, just click and apply. Okay, now just make the series here, terminals, and these two here, and we required L value, L and C, change to C, and it will be 20 microfarad. C will be 20 microfarad. Okay, L will be 700 and 63, 63.69 Henry, microhenry. Now we will connect these two here. For that, we will connect the load across it, and we can calculate the load value as the R resistive load, and it will be 5.4 ohm. Okay, we will also add a voltage measurement here to measure the voltage across it, voltage across the capacitor. Okay, and also the current measurement, the current through the resistors, we will going to measure it. Select go to and change these to I0 output current, and this will be V0, the output voltage. Okay, now select from block, okay, change to this S1. Okay, S2, S3, S4. Okay, now we need to design our controller, voltage controller. Now in subsystem we required a sum block, change to plus minus, and take a gain block. Okay. Change these to 1 by 54 volt as the output is we are converting it to low voltages. Okay. Do this here and take a constant block, constant, and the amplitude will be 1. 1 by 54 this will be, and again take a another subsystem where we will design our, change these to PI block, PI controller, and take one saturation, change the limit to the upper limit will be 0 and 0.5. Okay, and here take one sum block, sum after that again. Okay. Let's copy it and require a integrator with limit. Okay. And change this upper limit to 0.5. Okay. And change the ki value to 100. Okay. As our PI controller has been designed, now we will going to design the PWM for the how the PWM will be generated. For that, take a constant block. Okay. Change this value to 0.5. Take a logical operator, relational operator. Okay. Set to greater than. Okay. Now change to not. Okay. And you can change this type as distance. Okay. We can going to use like this, and repeating sequence. Okay. Connect to here and this one, and connect it here. Change to S2. Okay. Now copy this, and we will going to compare with signal. Okay, going to be check add block. Yeah. We'll take one signal from here, the comparison of those, and after that we will make then subtract that signal, and after that we're going to need one more add block. Okay. Change to plus plus. Okay. Now and copy this constant block as well. Now we'll compare it and repeating sequence. So output of the repeating sequence is going to compare, and we are going to take the one add block here, and we will add these two signals, the constant and the constant signal and the output of the PI, and we will going to change these two less than. Okay. We will set this value to greater than, and we will compare this with the repeating signal. Okay, the repeating sequence, and we will take a AND gate, and we will take the output from there, and we will feed it to these two, the plus, and we'll take change to S3. Okay, and take AND gate, make these two S4. Now we will change this value low, and the value will be the 1. Okay, now our PI controller has designed. Now we'll give the signal to connect to S1, S2, S3, and S4. Change to S2, S3, and S4. Change this to, this is S3, this will be S4. Okay. Select power GUI, change to discrete, change the time to 1 e raised to 6, 2, and For measuring the voltages, we require the scope. We'll measure the output voltage, output current. Okay. We need to connect these two here, and we have to take the one terminal from the, as it is center tapped transformer, we have to take this and we have to connect it here. And now let us run our simulation. As we can see that the voltage has been tracked exactly 10, and the current is also tracked, and the voltage is 54 volts, and it has been tracked here. If you haven't subscribed my channel, please subscribe it for the new updated videos. Thanks for watching.